Hello friends, in the previous video we have discussed about the first principle of differentiation. Okay, so today we will discuss about the differentiability at a point. So a function f is said to be differentiable at a point C if both f dash of c plus and f dash of c minus exist. This is the first condition, and the second condition is f dash of c plus is equal to f dash of c minus, that is right hand derivative must be equal to left hand derivative. And what is c here? C is constant number. Okay, any constant number which is given to you. So these two are the condition for any function to be differentiable at a given point. Okay, now how to find the left hand derivative and the right hand derivative? So the formula for finding the left hand derivative is limit x tends to c minus f of x minus f of c whole divided by x minus c. This is one formula, and another formula is limit h tends to 0 f of c minus h minus f of c whole divided by minus h. Okay, so this is these two are the formulas for finding the left hand derivative, and I will say you the most important formula is this. Okay, limit h tends to 0 f of c minus h minus f of c whole divided by minus h. This formula is better for solving left hand derivative. And how to find the right hand derivative? Limit x tends to c plus f of x minus f of c whole divided by x minus c, or limit h tends to 0 f of c plus h minus f of c whole divided by h. So as for the left hand derivative, for the right hand derivative also this formula is better for solving the limit. Okay, now we will solve one question to see its process. Okay, so our question is, test the differentiability of the function f of x at x is equal to 3. So f of x is equal to x plus greatest integer function of x. So how greatest integer function works? Suppose we have 2.1 greatest integer function. Okay, so we have to find the greatest integer function of 2.1. So the greatest integer function of 2.1 is 2. Okay, and if we have to find the greatest integer function of 1.9, then it will be 1. Don't take the closest value. The greatest integer function says that take the integer value less than this decimal values. Okay, if we have to find the greatest integer function of 2.1, then it is 2, and if we have to find the greatest integer function of 1.9, then it is 1. Okay, it always take the integer value less than the decimal value in the greatest integer function. So let us solve this question. Now first we have to find the right hand derivative. For right hand derivative we have to find the f of c and f of c plus h. So what is c here? C is equal to 3. So f of c, it will be f of c, that is f of 3, it will be f of 3 is equal to 3 plus greatest integer function of 3. So the greatest integer function of 3 will be 3. So 3 plus 3 is equal to 6. So f of 3 is equal to 6, and f of 3 plus h, f of 3 plus h, it will be 3 plus h plus greatest integer function of 3 plus h. Okay, now this is for the right hand derivative, and for the left hand derivative f of 3 minus h. So f of 3 minus h it will be 3 minus h plus greatest integer function of 3 minus h. Okay, now for the right hand derivative, first we have to find the right hand derivative. So right hand derivative, what's the formula? The formula is limit h tends to 0. Okay, limit h tends to 0 f of 3 plus h, which is c plus h, f of 3 plus h minus f of 3 whole divided by h. This is the formula. Now limit h tends to 0. What is f of 3 plus h? We have f of 3 plus h is equal to 3 plus h plus greatest integer function of 3 plus h. So 3 plus h plus greatest integer function of 3 plus h minus f of 3. Now f of 3 is equal to 6 whole divided by h. Okay, now we have to solve this limit. Limit h tends to 0. 3 minus 6 is minus 3. So h plus 3 plus h greatest integer function of 3 plus h minus 3 whole divided by h. Now how to solve this greatest integer function of 3 plus h? Our h is 0. Okay, so take h is equal to 0.1 as a rough. So 3 plus h means 3 plus 0.1. What it will be? 3.1. So greatest integer function of 3.1 will be 3. Okay, so limit h tends to 0. H plus 3 minus 3 whole divided by h. Now these 3 and these 3 get cancelled. So our limit will be limit h tends to 0 h by h, which is equal to 1. So right hand derivative we got 1. Now to solve for left hand derivative. So left hand derivative, limit h tends to 0 f of 3 minus h minus f of 3 whole divided by minus h. Now limit h tends to 0, f of 3 minus h is minus 3 minus h plus greatest integer function of 3 minus h, and f of 3 is equal to 6, which is minus 6 whole divided by minus h. Okay, so limit h tends to 0, 3 minus 6, it will be minus h minus 3 plus greatest integer function of 3 minus h whole divided by minus h. Now see here, greatest integer function of 3 minus h. Take h as 0.1. So 3 minus 0.1 will be 2.9. So greatest integer function of 2.9 is equal to 2. Okay, so limit h tends to 0, minus h minus 3 plus 2 whole divided by minus h. Now limit h tends to 0, minus h minus 1 whole divided by minus h, which is equal to limit h tends to 0, h plus 1 divided by h. Now if we will put h is equal to 0, then it will become infinity. So our left hand derivative we got infinity, which does not exist. Okay, so it does not satisfy the first condition, and also the left hand derivative does not is equal to the right hand derivative. So we have got right hand derivative is equal to 1, and left hand derivative we got infinity, which does not exist. Okay, so left hand derivative does not satisfy the first condition, the limit doesn't exist, and also the left hand derivative does not is equal to the right hand derivative. Hence the function f is not differentiable at x is equal to 3. Okay, hope this video is helpful for you. If you like my video, then please subscribe my channel. Thank you.